Hello, welcome back. The title of this lesson is Adding Positive Fractions and Mixed Numbers Part 1. What do we mean by adding positive fractions and mixed numbers? Well, we've now learned how to add and subtract negative and positive numbers, right? And so on the number line, we have all of the whole numbers, the positive ones, and the whole numbers that are negative, and we call those all together the integers, the positive and the negative whole numbers. But we do have fractions. All of the fractions live on the number line as well. Some are positive, off to the right, in between all the integers, and some are off to the left, negative fractions as well. So now we're going to just use our skills to add and subtract negative and positive fractions, right? So here we're going to start with just adding a positive fraction to another positive fraction. We always expect to get a positive answer. Positive plus positive is positive. So this is mostly a review in adding fractions, but in the next concept here in a few minutes, we will be adding negative fractions together, and so we will be using the ideas that we have learned about recently. So let's just crank through with the idea of adding a positive fraction. Let's say in this case it's 1/4, and we'll add that to another positive fraction, 3/8. Now, as you know, or in case this is a review, in order to add fractions, here we have a denominator of 4 and a denominator of 8. We have to have the same denominator in order to add fractions. You always do. Now in this case, we have a fraction of 1/4 and the denominator is a 4, and here we have a denominator of 8. Obviously they are not the same thing. Let's take a look and see what these fractions actually look like. Here is the fraction 1/4. I'll just kind of put it right next door like this. And then the fraction 3/8 is 1/8, 2/8, 3/8, because these little wedges are in eighths of the circle. So what we're really doing when we take 1/4 and we add it to 3/8 is we're really taking this amount and we're putting it together. And the total amount when you add them together is this much of a circle. But because they're all expressed in different sizes, and this one's in fourths and this one's in eighths, it's very difficult to figure out what the answer is. Even though we can put it there, we want to write it as a single fraction. So we need a common denominator because that'll make all the slices we're adding together the same size, right? Right now they're different sizes. So the good news is we can change one or both of these fractions anytime we wish, because we can multiply our fraction on the top and the bottom by the same number. Remember, when we multiply the top and the bottom of a fraction, it's like a seesaw. It remains balanced. If we multiply the top by 2, we can maintain balance by also multiplying the bottom by 2. If we multiply the top by 6, we can multiply the bottom by 6 as well. In this case, our original fraction is 1/4, and we're adding to it the fraction of 3/8, right? Now, how can we change this fraction? It's originally 1/4. How can we make it have the same denominator as this one over here? Well, we're free to do what we want. We're going to multiply the bottom by 2, and then that means we have to multiply the top by 2 to maintain balance. 4 times 2 is 8, and then we will have the same denominator. So what we would then have is 1 times 2 is 2, and 4 times 2 is 8, if I can write 8 correctly. And over here, we'll be adding it to, of course, the 3/8. So in this case, we did not change the original fraction that we had over on the right-hand side. We didn't change it at all because we only had to manipulate one of them to get the same denominator. In this case, you can do that, but in some problems, you have to multiply both fractions by something on the top and something on the bottom in order to get the same denominator. Now, what does 2/8 really look like? What we're saying is 2/8 is the same thing as 1/4. Multiplying top and bottom by 2 just changes the way it looks. So 2/8 looks like something like this. That's 2/8. And 3/8 looks like something like this, 1, 2, 3. Remember, that didn't change. That stayed the same from before. And if you notice, the 1/4 that we started with is exactly the same size and shape as 2/8. So we're totally fine adding 2/8 to 3/8 because 2/8 is exactly the same as what we started with. It just looks a little different. Now, when we add these fractions, what we want to do, I'll put a little equal sign here, is the denominators are equal and they stay the same. The numerators we add, 2 plus 3 is 5. We add the numerators together. 2 plus 3 is 5. So we're saying that the answer to this problem is 5/8. And so let's take this and let's move it over here and see if this makes sense. We move it over here like this. So that's 1, 2, 3. 4/8 and then 5/8. What we're saying is that when we take the original two fractions and change the way one of them looks, we can add the numerators, keep the denominator for 5/8, and this is the amount of pizza that we have. In our original problem with our original fractions, if we just put them together, you can see that this amount of pizza is exactly the same as what we got for our answer. So we know that we put them together is what we call addition. Here, it's exactly the same amount, it's just expressed as a single fraction, so that's why we do it that way. Okay, the first problem always takes the longest. In the remaining problems, we'll go a little bit faster, but ultimately we have to change one or sometimes both of the fractions in order to change the way they look. And then after that, we just add them as usual. And we also try to simplify the answer. In this case, 5/8, we cannot simplify it any further because we cannot divide top and bottom by some common number to make it any simpler. So let's move right along and see if we can make sense of problem number 2. Problem number 2 is 1/6, and we're going to add to that 1/3. Now, the fractions have different denominators, so we need to change one or both of these guys. Notice that 3 times 2 is 6, so we can have it match this guy. But before we go any farther, let's try to see if we can make sense of what this looks like. 1/3 is this amount of a pizza, and 1/6 is this amount of a pizza. So this is a smaller slice there. So this is what we're adding together, this plus this. Now, if we can physically pick it up and put it over here, this is what the addition will look like. Now, what do you see here? If you turn it sideways, maybe it's a little easier. Once you add these there, you can see that this is going to be exactly half of a pizza, right? So that's kind of giving away the punchline, but let's go through it, and you know that at the end of it, you should get 1/2, right? So we're going to start by keeping my 1/6 intact, and we're going to add to that 1/3. Right? But we're going to change the way the 1/3 looks. We're going to multiply the bottom by 2, and then we're going to multiply the top by 2. So what this is going to do is it's going to make 1/6 here plus, and this is 1 times 2 is 2, and 3 times 2 is 6. So what we have basically said is that the 1/6 stays the same, but now we're saying that 2/6 is exactly the same as what we had over here as 1/3. You can kind of see this here. This is 1/6, and this we're saying 2/6, so I'll go ahead and put this in place. There's 2/6. You can see that 2/6 is indeed exactly the same thing as 1/3. We're just changing the way the problem looks. We're changing the way this fraction looks, but it's the same amount of material that we're adding together. So how do we add these guys? Right, well, we have a common denominator, so we keep that denominator, and we add the numerator. 1 plus 2 is 3. 3/6. Now, what we do when we have a fraction, we try to simplify it. 3/6 we can simplify because we can divide the top and bottom by any number we want. We'll divide by 3, and what do we get? 3 divided by 3 is 1, and 6 divided by 3 is 2. So look at what we got. The answer was 1/2, which is what we predicted from before. So if we were to take this 1/6, let's move it over here, and then we add to it 2/6, which is exactly what we did right here. Notice that we get exactly half of a pizza, which you can convince yourself, because this is the fraction 1/2, it covers it up exactly there. So the answer is 1/2. So when we take 1/6 plus 2/6, we get 3/6, and this 3/6 is the same amount as the simplified fraction 1/2. So we would say the original fraction 1/6 plus 1/3 is 1/2. So we're only going to use these magnets here for the first couple of problems. We're going to drop them very soon, but it's good to have a visual of what you're doing. When you change the fraction by multiplying top and bottom by some number, it changes the way the fraction looks, but it doesn't change the amount. 1/3 is this much stuff, but we multiplied and we made it 2/6, which was exactly the same amount of stuff, right? So when we add it together, it's giving us the same answer as we predicted ahead of time, remember? Because when we originally did this, we said we should get half a pizza, which is exactly what we get. All right, I think we'll do 2 more with the magnets and then we'll drop it. Let's take a look at problem number 3. What about 1/2, and we'll add to that 3/10, right? 1/2 and 3/10. So what do we do first? First we say, well, what does 1/2 look like? 1/2 of a pizza looks something like this. And what does 3/10 look like? Here's 1/10, 2/10, and 3/10 of a pizza, right? So we're going to take this amount and literally stick it on there. That's what we're going to get as an answer. How do we represent it as a fraction? Well, we see that we have 1/2 here. So we'll rewrite the problem as 1/2, and then we'll represent it here or add to that the 3/10. Now we can change this into a 10 very easily by multiplying this fraction by 5 on the bottom, and then we have to match it to 5 on the top. Right? What does that do? Well, 1 times 5 is 5, and 2 times 5 is 10, and then we'll add to that 3/10. Okay? So what have we done here? We've changed the way the fraction looks. So let's go and say 1/10, 2/10, 3/10, 4/10. This is 5/10. So this is what we get for 5/10 right here. Notice that it makes exactly half of a pizza because 1/2 is the same thing as 5/10. And then we're going to add to that 3/10 from here. We didn't change that at all. So here's my 3/10, same as before. But the difference is because now both of the fractions have the same denominator, the slices of the pizza are all the same. So if I really want to add them, how do we add them? What we're going to do is keep the same denominator and add the numerators. 5 plus 3 is 8. 8/10, right? But 8/10 can be simplified because we can divide the top by 2 and the bottom we can divide by 2. Right? So what we're going to get here is 8 divided by 2 is 4 and 10 divided by 2 is 5, and the answer is 4/5. 4/5. So remember, we started with 1/2 plus 3/10. That's this plus this. We changed this to be looking like 5/10, but it's still a half a pizza. Now if we take this and add it to 3/10, what do we get? We get 1, 2, 3, 4, 5, 6, 7, 8/10. That's exactly what we said. But we said we could simplify 8/10 into 4/5. And when we grab and see what fractions in terms of fifths look like, here's 1/5, here's 2/5, here's 3/5, and here is 4/5. Now if I bring this over here and hold it right next door, you can see that 4/5 is exactly the same amount of material as these. When we add these together, we get this much stuff. 4/5 is the same as the 8/10 that we get right there. All right, so sometimes by using these kind of magnets or pictures, you can really get a good visual for what you're really doing, which is the whole point. All right, let's take a look at the next problem. The next problem is going to be 3/4, and we're going to add to that 4/8. So we need a common denominator. We can take this fraction and multiply it by 2 because 4 times 2 is 8. And we'll do it to the top and the bottom, and that will give me a common denominator there. Before we go any farther, let's see what 3/4 looks like, and let's see what the other fraction looks like as well. So 1/4 right here, then 2/4, 3/4. This is what 3/4 looks like, and we're going to be adding it to 4/8. So here's 1/8, 2/8, 3/8, 4/8. Now notice what's happening. If we actually try to add these together, notice that we make an entire whole pizza, but we have more left over. So when we add these, it's so much material that we're going to make one whole pizza plus 2/8 left over. So the answer is going to be 1 and 2/8, which we can simplify later, but I want you to understand that you are going to get more than one whole answer, more than one whole pizza here before we even get started. So let's just kind of put this in place and kind of do it mathematically and see what we get and see if we actually get the correct answer. So let's take this first fraction. Let me see if I can tuck this up, kind of hide it up there, something like this. Let's take this 3/4 and let's multiply the top and bottom by 2. Whoops, if I can write it correctly. Multiply the top by 2 and also the bottom by 2. The second fraction we're going to leave totally alone. We're not going to do anything to it. What does this do for us? Well, what this does for us is it makes 3 times 2 is 6, and 2 times 4 is 8. And then we're going to add 4/8 to it, right? Does this make sense? Well, yes, because this 6/8 we're saying is exactly the same thing as 3/4. This 4/8 is exactly what we have started with, all right? So now to add these guys, we keep the same denominator, and we add 6 plus 4, and we get 10/8. So notice that we have an improper fraction now. When you have a top numerator larger than the denominator, it just means that you have more than one whole. Because 8/8 would be a whole, you have more slices in that, so you know that you're going to get something more than one. All right, we can simplify this. We can take the 10/8 and we can divide the top by 2 and the bottom by 2, which will give you 10 divided by 2 is 5 and 8 divided by 2 is 4. Still get an improper fraction. How do we convert an improper fraction to a mixed number? Well, we do the division, right? So what we say is that 5 divided by 4, that's what this means. 4 can go in one whole time. 4 times 1 is 4. The leftover, 5 minus 4 would be 1, and it's out of 4 pieces. So what we're saying is 1 1/4 is exactly the same thing as 5/4. So let's see if we can make sense of this. What we're saying is originally we took 3/4. That's how much we started with. And we added these 4/8 here. Now 2 of them are going to tuck in and make 1 whole. And then these 2 are going to go over here and make left over what we have, right? So what we're saying is that we got an answer of 10/8 because if you slice this up into 8s, notice it's 1/8, 2/8. This could be 3 4/8, 5 6/8, 7 8/8. 8/8, then 9 10/8 here, and that's the same as 1 1/4. So 1 whole is right here, and 1/4 is what's left over. Notice the 1/4 is exactly what is left here. So 1 1/4 is exactly the same thing that we get when we actually try to add these guys together. All right, the magnets are great. I really like it to introduce the topic because we're all visual people, you know, most of us are, and sometimes seeing something visual can really help us remember what we're doing. But from now on, we are not going to use the magnets anymore because, you know, we have to at some point take the training wheels off and just start to solve the problems. All right, next problem. Let's take a look at 2/3, and we're going to add to that 10/12. How can we find a common denominator? Well, we know that 3 times 4 is 12, so we can change this fraction to give us our common denominator. We're going to take the 2/3 and we're going to add it to 10/12 as usual, but we're going to change this fraction by taking and multiplying the top by 4 and the bottom by 4 because 3 times 4 is 12 and then it will match. So what do we get? 2 times 4 here is 8, and 3 times 4 is 12, and we're still adding to 10/12. But now we have a common denominator. So we keep that denominator, and we add the numerators. 8 plus 10 is 18. And what you have there is 18/12. Now these are even numbers, so we can simplify this. 18/12. We can divide the top and bottom we can divide by 2, but we can actually save some time by just dividing by 6 because they're both divisible by 6. 18 divided by 6 is 3. 12 divided by 6 is 2. So 3/2 is the correct answer, but we can change it to a mixed number by dividing. How many times will 2 go into 3? It will only go 1 time because 2 times 1 is 2. The leftover remainder, 3 minus 2 is 1, and it's out of 2, so it's 1 1/2. So the answer to 2/10 plus 10/12, because they're such large fractions, you get an answer bigger than 1, and the answer you get is 1 1/2, or you could write it as an improper fraction, which is just 3/2. All right? Almost done. Let's crank along with the next problem. Now we're going to change it a little bit. Let's give 1 1/3, that's a mixed number, and we'll add to that 2 1/4. So we have 2 mixed numbers we're adding together. My advice to you, when you're dealing with mixed numbers, you don't have to do this. Okay, you could add the whole numbers and then you could add the fractions, but actually what I want you to do is just change them to improper fractions all the time. And then add them, and then change them back. Because when you multiply and divide these mixed numbers, it's just always going to be easier to deal with them as an improper fraction. So what we do to change these things is, we take this, 3 times 1 is 3, plus 1 is 4, and make it out of 3 on the bottom. So this is 4/3. And then this is 2 times 4 is 8, plus 1 more is 9, and make this out of 4. So you see now we're saying that 4/3 is the same as this, and we're saying that 9/4 is the same as this. Now how do we get a common denominator here? We have a 3 and a 4. In all the other problems, all I had to do was change one of these fractions, but here I can't do it. So I have to pick some common denominator I'm going to shoot for. I know that 3 times 4 is 12, and I know that 4 times 3 is also 12. So I'm going to pick 12 as a common denominator. So 4/3, I'm going to add to that 9/4. And in order to get that denominator of 12, I multiply by 4 on the top and the bottom, and here I multiply by 3 on the top and the bottom. What's that going to do? Well, I'll get a denominator of 12 because 4 times 4 is 16, 3 times 4 is 12, 9 times 3 is 27, and 4 times 3 is 12. So you see, I have 2 common denominators, 16 out of 12, or 16/12 and 27/12. So what I need to do to add them is the denominator will stay the same. I have to add the numerator, 16 plus 27. Now, if you want to count on your fingers, if you want to go off to the side and add these numbers, that's fine. You want to use a calculator, that's fine too. I'm assuming that you now know how to add numbers. So when you add 16 plus 27, you can think of it going up 27. 10 more is 37. And then with 6 more is 43, right? So you're going to get 43 on the top. So again, going up 10 is 37, then 6 more is 43. And that's going to be out of 12. 43/12. So we have a big improper fraction, and let's convert it to a mixed number. 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. And 12 times 4 is 48. So it cannot go 4 times. That's too big. So it can go 3 times. 12 times 3 is 36. When you take 43 and you subtract 6 from it, you're going to get 7. 43 minus 36. 43 minus 36, you're going to get 7. And then it's out of 12. So essentially what you're doing is you're doing this long division here, right? I guess we could go off to the side and do 43. We're dividing it by 12. We're saying that 12 times 3 is 36, right? And you can borrow, make this a 13, or however you want to think about it. If you borrow and make this a 13, then 13 minus 6, then 13 minus 6 is going to be 7, and then you borrowed, so this will be a 3 minus 3, which is 0. So what we're saying is it goes 3 whole times with a remainder of 7, and it's out of 12. So it's 3 and 7/12. So I know it's a little bit of a pain, but my advice is when you have mixed numbers, change them to improper fractions. It's going to make your life a little bit easier. All right, let's take a look at our last problem. Let's say we have 1 and 3/8. And we're going to add to this 2 and 1/2. All right, again, you could add the whole numbers and then add the mixed numbers, the fractions, but there's some gotchas there I don't want to have to really deal with. So instead of doing that, let's just change them to improper fractions. 8 times 1 is 8, 9, 10, 11. So this is 11/8. 2 times 2 is 4, 1 more is 5. So this is 5/2. So we have 11/8 and we have 5/2. We have an 8 and a 2. How do we find a common denominator? Well, I'm going to keep the 11/8 the same, but I'm going to add to it 5/2, but I'm going to change that 5/2. I'm going to multiply the top and bottom by 4. All right? What's that going to do? Well, I'm going to have 11/8, and then 5 times 4 is 20, and 2 times 4 is 8. So I have 11/8, and I'm adding to it 28. So the denominator is the same, and 20 plus 11 is 31. So I'm going to have 31/8. So the answer is 31/8, but we can change this to a mixed number. 8 times 4 is 32. That's too many times. 8 times 3 is going to go 3 times. 8 times 3 is 24. And when you take and find the remainder, 31 minus 24, you're going to get 7, right? And so you're going to get 7/8. Now I'm kind of doing some of this in my head. You could do the long division. I mean, you could just go there and take 31, divide by 8, and figure out what the remainder is. What's going to happen? 31 divided by 8. You say 8 times 3 is 24, right? And then you're going to have to borrow, make that an 11. And then 11 minus 4 is going to give you 7. And then you borrowed, so that'll be 2 minus 2 is 0. So you're basically going to get a 7 right there. In other words, 24 going up to 30 is 6. And then 1 more is 7. So the remainder there is 7. But in your head, you can eventually get good at figuring out 31 minus 24 is 7. There it goes, and it's out of 8. So 3 and 7/8. So here, we've been basically reviewing addition of fractions. We're doing a positive fraction, adding to it another positive fraction. Notice every time it was positive plus positive gives me positive. Positive plus positive gives me positive, and so on. Follow me on to part 2, where we're going to do more of these with slightly larger numbers, get more practice. But then after that, we'll be adding negative fractions to positive fractions, and we'll have to use what we now know about adding negative numbers to handle that. So for now, go through all of these, make sure you understand how to get the right answers. Follow me on to part 2 of adding positive fractions and mixed numbers.